name is Prithvisha Nath and I am the TA for this course Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering. So this is week 1 for this course. Every week we will solve some questions and you should also try solving the questions along with me. So let's start solving the questions. Which one of the following statement is true? So there are two cases, case 1 and case 2. So in the first option it is said both cases are not equivalent since force is applied at different point. In the second option, both cases are not equivalent since the position vector of the point of application of force with respect to P is not the same. Both cases are equivalent as both will identically have only translation, and for the last option is both cases are equivalent since both can be represented by the same force and couple system about point P. So can you tell me which option is correct?
Not equivalent.
Sorry?
Both cases are not equal and forces applied in different points, right?
So which option?
First one,
No.
am I audible?
Yeah, you're audible.
Which option?
Option 1, ma'am.
No.
See, this force is a
See, this force can.
Hello, am I audible?
Now you are audible, ma'am. You are audible.
See, force is a sliding vector, so we can slide this force along the line shown, this black line which is shown here in this image. So we can slide this force. Now we can bring this force in the same position as shown in case 1. So we can easily represent this by the same force, and it will have the same and it can be represented by the same couple system about the point P. Now if I slide this force up here, like in the same position as the first case, I can easily do that, right? Since
Yes, ma'am.
force is a sliding vector. So option 4, like the fourth option is correct.
Both cases are equal.
Did you understand?
Yes, ma'am.
Okay. So both cases are equivalent since both can be represented by the same force and couple system about point P. So let me explain the first question once again. So these are the four. So here is a picture that shows two cases, as you can see. Now there are 4 options to this question. First option is both cases are not equivalent since force is applied at different point. The second option is both cases are not equivalent since the position vector of the point of application of force with respect to P is not the same. And both cases are equivalent as both will identically have only translation. And fourth one is both cases are equivalent since both can be represented by same force and couple system about point P. So here option 4 is correct since we know that force is a sliding vector. I can shift this force along this line of application to this point, like the same position as shown in the first case. So I can easily represent it by the same force and the couple system about the point P. So the option 4 is correct. Now for the second question, a rigid square ABCD is subjected to planar forces as shown with the magnitude of the forces. Force P is 20 Newton. Based on the given data, answer the following questions. So the net resultant force acting on the rigid square is. Can anyone solve this question? Can anyone try solving this question? So force P is acting on this rigid square, and you need to find the resultant force acting on the square.
Twenty Newton. Answer, madam.
20.
Yes.
Okay, so let me explain it. Anyone else? Can anyone else try it out? So yes, the correct answer is 20 only. So let me assume this is my coordinate system. So if I write summation of force in the x direction, so what can I write? The force acting at point A can be denoted as plus 20, and force acting at point C is minus 20. So net force along x direction is 0 Newton, right? Now I will calculate the force along y direction. So it is minus 20. So the net resultant force will be 20 newtons. So for the same question, we need to find the net moment acting on the rigid square about the point A. So about this point we need to find the moment. So which force will contribute to the moment? Can anyone tell me about point A? Yes. So the force acting at point C will only contribute to the moment. So moment about A I am representing by this. So if I consider anti-clockwise movement to be positive, my answer would be P into 5, that is 20 into 5, 100 Newton meter. So the third option is correct. Did everyone understand up till this question? Anyone has any doubt? You can tell me if you have any doubt. So I will move on to the next question then. this question, it is said that the resultant of two vectors A and B is R as shown in case 1, as you can see. If B is doubled in case 2, the new resultant is R1, which is perpendicular to A. You can see that for the case 2, the magnitude, the vector B is doubled and the resultant R1 is perpendicular to the vector A. So, what can be concluded about the initial set of vectors? Now, can anyone solve this question? Any one of these options are correct. Can you tell me which one is correct from this? So here is the question. You can try it out. I will solve it after that. Is anyone trying to solve this question? So, I will solve this question now. Did anyone get the answer? You're not audible. Okay, so I'll solve the question. So, for the first case, so this is case 1. So I can write the resultant vector as suppose this is the first equation. Now from the second case, it is mentioned that R1 is perpendicular to vector A. So what can I write? I can write that the dot product between A and R1 is 0 since it is 90 degree. Therefore, is there any doubt up till here? Okay. So now from the second case I can also write vector R1 is A plus twice of vector B. Now let it be equation number 3. Now I will substitute equation number 3 in equation number 2. So what will I get? A plus 2B dot of A dot with A equals 0. Now I am simply calculating the dot product. Now from here I can find out cos theta in terms of magnitude of A and B. So cos theta becomes minus of let this be equation number 4. Now I will substitute this value of cos in the first equation, this equation. So this simplifies to so what do I get? Magnitude of vector R is equal to this. So which option is correct? The third option is correct. So did everyone understand this? If you have any doubt, you can tell me. So if you have any doubt, you can tell me. Okay. on to the next problem. So, the total internal angle at each vertex of the symmetric star is 36 degree. The total internal angle at each vertex of the symmetric star is 36 degree. And it is known that the vertical distance AO is twice the clear perpendicular height of the arm as shown. So, we are asked to find the position vector of the vertex B, position vector of this vertex B with respect to vertex D. So, D is taken as the origin as per the question. So, I want everyone to try this question. The total internal angle at each vertex is 36 degrees. So, this angle is 36 degree. And this total height AO is 6 meter. Now with this data you are asked to calculate the position vector of vertex B with vertex D taken as origin. So this is the question, you can try it out. So I'll solve this question. Did anyone get the answer? So I'll solve the question now. So let this be A. Let this be A. So what can I write? I I can write A cos of 18 is equal to 3 meter. A cos 18 degree is 3. So from here I'll get A as 3 divided by cos of 18. Now, what is, let this point be E. So, now I will complete this triangle. So, this angle is also 36 and this is 90. So, can anyone tell me what will this angle be from this triangle? Yes. So this angle is 54. Now, so I can say this angle is also 54 degree, right? Did everyone get this point? Okay. So, since this is 54 degree, now I can find out OE because this length OC is also equal to A. Now, what is OE? OE is A of cos 54. That is, I'll substitute the value of A, 3 divided by cos of 18 into cos of 54. So I get 1.85 meter. Now, to find out this coordinate of B with respect to D, I got this height as 1.85. I also know this height B. This, suppose this is from here to here. I know it is 3, right? Since this total height AO is 3 and the upper, it is also shown that this part from here to here it is 3. So I can say this is 3 meters. So the x coordinate of B will be x coordinate of B is 3 plus 1.85 meter, that is 4.85 meter. Sorry, this is y coordinate. Sorry, y coordinate. Sorry, this is y coordinate. Now I need to find out the x coordinate. I got the y coordinate. Up till here, anyone has any doubts? You can tell me. If anyone has any doubt, you can tell me up till this point. Is there any doubts? Okay. So, to calculate the y coordinate, x coordinate means this distance. I need to find out this distance. So, what is this length of BD? BD, the distance between the point B and D. BD can be written as twice of A plus OF. Let this point be F So this is a BF. The length of BF is A, length of OD is also A, so it becomes 2A plus length of OA. So length of BD is twice of A plus OF. Now from triangle OCF, this triangle, from this triangle I can find out the value of OF. Now from triangle OCF, I can write this as A square equals to 3 square plus OC OF, sorry. Did everyone understand why did I write this? From this right angle triangle, A square equals to half of OF plus 3 square. Now from here OF can be written as now I'll just rearrange this equation. Now did everyone understand this? Did everyone understand this? Up till this point, did everyone understand? Okay. So I got OF. So I know BD is twice of A plus OF. Now I'll just simply substitute BD equals to I'll take 2 as common and I'm directly substituting. So this comes out to be 8.26 meter. Now I got BD. BD is this entire distance between point B and D, and I know this perpendicular height, that is the y coordinate. So if we can see it's a right angle triangle, so from Pythagoras theorem I can easily calculate the x coordinate, that is this distance. So x coordinate is 6.68 meter. And since it is and the z coordinate is 0, as you can see, it lies in a plane. This star lies in the xy plane, so the z coordinate is 0. So which option is correct? The second option is correct. Now it is asked to find the position vector of the vertex E with vertex D taken as the origin. Now we need to find the position vector of this point with respect to this vertex D. Since B and E lies in the same height, so the y coordinate will remain the same, that is 4.85. So we can say that the y coordinate of both point B and E will remain the same. So y coordinate of E now I need to find the x coordinate. That is this distance. This distance. Can anyone tell me it should be negative or positive? By looking at the problem, like just by looking at the picture, can you tell me it should be negative or positive? Yes, since it is on the left side of the coordinate system. Now let this point be something else, like we already have this coordinate as E, so I'll write this something else. So let this be G. Now OG, accordingly I should change it. So from this triangle OE, this distance between E, point E, that is vertex E, and this point O, what is the distance? I can write it as A plus some let this be H. So A plus H O H, right? So now I just substitute this. A was 3 by cos 80. this comes out to be 5.10 meter. Now OH Now I know the distance between E and O. So I can calculate this distance. This distance we already know, this is 3. So I can calculate this distance. This distance, right? So let this be I. So OI can be written as 4.12 meter. X is, so this particular distance is this distance OI minus of DG, right? That is A cos 36. Now this distance is 1.58. Now since this is on the left hand side of the coordinate system, I will take this as negative of this value. X coordinate of E is minus 158 So I'll directly write it as a position vector. Position vector of the vertex E vertex E will be minus 1.58 I cap plus 4.85 J cap plus 0 K cap. So which option is correct? The last option. Yeah. So did everybody understand this question? It's a lengthy problem, but did everyone understand? If you have any doubt, you can tell me. Is there any doubt in any part of this question? Okay. So the next problem, the total moment in Newton meter on the star with respect to the vortex D. So I need to find the total moment with respect to the vertex D. So can anyone tell me which force will contribute to the moment about point D? The one which is acting at E or the one which is acting at B? Which force will contribute to the moment? Yes. Yes, E will the force which is acting at E will contribute to the moment. Now I need to find the perpendicular distance between the line of action of force and this point D, which is this distance, right? Is this point clear? That this is the perpendicular distance? Okay. So what is this distance? This angle is 18 degree, and so this distance is A cos 18 degree, right? So the moment about D is 20 into A cos 18, which is equals to 60 Newton meter. And what is the direction of this moment? What is the direction of this moment? Can anyone tell? Yes. So this is so if we consider anti-clockwise as the positive moment, so this will have a positive sign only. So anti-clockwise direction. Is there any doubt in this problem? Are the steps clear to everybody? Okay, so I'll solve the next problem. The cable AB used to raise the trap door OA, as shown, passes over the small frictionless guide pulley at B. The tension everywhere in the cable is T, and this cable pulls the door at A, causing a moment MO about the hinge at O. At the instance shown, the door is elevated at an angle theta 30 degree. Answer the following questions based on given data. So this angle is equal to 30 degree, right? So can everyone try solving this problem? And RAO is the position vector of the point A with respect to O in meters. So can anyone try solving this problem? It is comparatively easier problem. You can try solving this. You need to find the x component of the position vector RAO. Can someone tell me what is the x component of this position vector? So this is the x component. So simply it is, if I name this as C, this point, so OC is 0.7 cos 30 degree, which is equal to 0.61 meter. That is the x component. X component of position vector RAO is 0.61 meter. Is there any doubt? Yes, reaction force will be there, but we just need to calculate the x component. Of course, reaction force will be there. Okay. So there's no, is there any doubt with this problem? Like for finding out the x component? You can ask me if you have any question regarding this x component of position vector AO. So I'll move on to the next question then. Similarly, we need to find the y component of position vector. Y component Can someone tell me what will be the, how can we find out the y component? Can someone tell me how can we find the y component? Like this is the y component. So how can we find this? Yes, 0.7 of sine of, yes, exactly. 0.7 into sine 30, that is now length of the position vector of point B with respect to A in meter. So this length we need to calculate. So a hint is provided, use cosine rule. So can you try to solve this problem? This part of the problem, that is the length of the position vector B with respect to A. You need to use the cosine rule. Here is the picture. You can try to solve. You just need to use the cosine rule to find this length BA. So here you need to find the length, not the force. So to find the length you need to use the cosine rule. Understood? Yeah. So okay, so what is the cosine rule? Suppose this is a triangle. Now let this be a triangle. So and let these be the length. Now according to the cosine rule, a square equals to b square plus c square minus twice of bc cos of a, cos of this angle. So for the given problem we can use this concept. Now, so we can use this triangle OBA. So for the given problem, O, A, B, this is given as 0.55, this is given as 0.7. So, and this angle is given as 30 degree. So, angle BOA is 60. This angle is 30 degree and this angle is 60 degree. So how can we write this? AB square equals to 0.55 square plus 0.7 square minus of 2 0.55 into 0.7 into cos of this angle, the opposite angle to the side AB, right? According to the formula. So cos of 60 degree. So AB becomes 0.55 square plus 0.7 square plus 2. That is 0.638 or 0.64 meter. Is this clear? Is there any doubt for this part of the question? Okay. Now, the tension TAB is given. Let tension TAB represent the tension in cable AB, and value of the tension is 250 Newton. So we are asked to find out the x component at point A. So the tension is acting in this direction. Now again we need this triangle to find the angle. Here we will use the sine rule. We know from it is given that this side OB is 0.55, OA is 0.7, this angle is 30, this angle is 60, now, and AB also we know that is 0.64. Now by using the sine rule we can write it as 0.64 by sine 60 0.7 by sine of B. So beta equals to 0.7 into sine 60 divided by 0.64. So what is the angle B? Yes, 71.3 degrees. Now angle OBA now the tension is acting in this direction, right? Now if this is 71.3 degree, what is this value? Can you tell me? -90 minus 71.3, right? Yes. angle DBA is 90 minus 71.3. 18.7 degrees. Now, this is 18.7 degrees. So I can say this also as 18.7 degrees. Right? These two lines are parallel, right? Now the x component of tension will be tension is acting in the negative direction of x, right? The x component of tension is acting in the negative direction of x. So there should be a minus sign. Minus of, and the value of tension is 250 into cos of 18.7, that is minus 236.80 Newton. Up till this point, is there any doubt? Okay. So the next problem is we need to find the y component of the tension. So y component Now, can anyone tell me whether the sign should be negative or positive? The sign of tension should be negative or positive for the y component? Yes, since it will be upwards. Now, $80.15 Newton. Now moving on to the next part, what is the moment MO in Newton meter about the point O? So we need to calculate the moment about this point O. So how can we calculate the moment about this point? Can anyone tell me? Yes. Yes. So 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 can anyone tell me what is the answer for this? So for finding this, okay, I'll show the question once more. Can anyone tell me the answer? Here you need to find first you need to find the angle A. Again, using the sine law, I can find the angle A. So 0.55 divided by sine of A, 164 sine of 60. So sine of angle A is 48.09. A is 48.09. Angle BAO is 48.09 degree. So this angle is 48.09. This total angle is this angle is 48.09. Now if I resolve the tension along the along this direction such that it is perpendicular to this dot trap. If I resolve the tension along this direction, T into sine of 48.09, I will get a component which is perpendicular to this dot trap, right? Is this thing clear? This is perpendicular to the dot trap, right? If I resolve this T into sine of 48.09 will give me the perpendicular component. Yeah, and I already know OA 0.7, that is the distance. So I can find the moment from there. So MO is TAB sine of 48.09 into 0.7, that is 130.23. Newton meter. Is this part of the problem clear? Is there any doubt regarding this part? Is there any doubt regarding this part? You can tell me if you have any doubt in any of the questions that we solved today. Which problem? Which problem you want to see? Okay. Yeah, this is the figure. Yeah, it is the same tension, right? The tension is not changing. It is mentioned. See, in the question, the tension is same everywhere in the table. So, are there any other doubts? You can ask me if you have. So, are there doubts? Anyone else having any doubt? So, if there is no doubt, we can stop here then. Is there any doubt from anyone? Okay, so we shall stop here then if there is no doubt.